come back to it over and over again in the future and build off of some of these concepts. So today I wanted to focus on filling in the unit circle, and along the way review what that means, how to set it up, and what we really need to memorize and what we don't. So hopefully this will be a nice review or a nice learn and study along with me. And if you are wondering why I'm whispering, of course, it is to help you relax. So we're going to make a nice, beautiful, colorful unit circle today with some special values. So what I did was I already drew my x and y axes, so they are perpendicular to each other. They make up the xy coordinate plane, and I'm going to use my compass here. My compass. Love this thing. And put the point, the center at 0, 0, which is the origin. And the actual distance between the drawing part and the center doesn't actually matter, and that's because I am going to label my scale so that it is 1, so the actual physical distance doesn't matter. So I'm just going to pick one that seems nice. I don't want my circle to be too small because I'm going to label stuff. So I'm just going to go ahead and do this. And I'm just going to spin the pencil around while holding the center still. And just swoop it around. Swoop. And I'm just going to try my best to not move the distance. See, so that every point drawn here is the same distance to the center, which is my definition of a circle. Okay. I'm gonna make it nice and bold too, so go around a few times. Ooh, so beautiful. Okay, so basically the unit circle, of course, is a circle, but every point, now that we know that it's a constant distance, that distance is actually 1. So I have to actually label an axis so I can show you that it's 1, because if I label this, for instance, as 1, then that's a problem because that's a distance of 2, right? So I actually need this to be 1, and this to be 1, and this to be -1, but a distance of 1 to 0, and this is -1, right? So where the circle meets either the x or the y, those points need to be a distance of 1 to the origin, because any point on the circle is a distance of 1, and specifically those points. So this is a distance of 1. This is also a distance of 1, but I labeled as -1 because remember, when we plot points, left is negative, left of 0 is negative, so -1, but that has a magnitude of 1, a distance of 1. Same with this way and same with this way, right? Down is negative, up is positive. Okay, good. So basically this is my scale now, and if you were working the other way around, if you're given, a graph and it already has the axes labeled on it, you just need to find 1 and use this to measure that 1 and then swoop it around. And of course we want it to look like a circle, so hopefully your axes will be labeled so that the scales are the same, because otherwise your circle might not even look like a circle. So that's a silly little side note there, but for now our axes are the same, so 1 and 1. Okay, so remember we have quadrants as well, so the xy axes naturally divide this plane into 4 quadrants. Quad. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And if you've heard of this stuff before, these angles are probably not new to you. But the reason that they are special is because we know their exact x and y coordinates. Remember, when we plot points, we have ordered pairs, x, comma, y, x, comma, y, right? And it tells you like left or right and then up or down from 0, 0, right? So we have x and y coordinates, and when we plot the points that are associated with these angles, we can actually use geometry to get exact values. So a lot of the time, if I were to just pick a random point right here, I can't exactly tell you just by looking at this picture what that coordinate would be. I know I could estimate it. It could be like, oh, if this is -1, this is -1/2, -1/4, maybe -1/8, comma, something that's almost -1, but not quite. But I can't get an exact value. But these have exact values, and we can do those derivations in the future. I think they're really, really cool, so we'll do that soon, I think. But what I'm gonna do is first label those angles and find those angles on this point. So we can basically find 30 degrees. So if 0 is positive x here, positive x-axis, that is 0 degrees. 30 degrees is right here. Okay. And so this thing is a protractor, and we'll work with this some more in drawing angles, but for now I'm just going to go ahead and use it. So we have 30 degrees, we have 45 degrees, which is between 40 and 50, and then we have 60 degrees, right? 30, 45, and 60. So I made those little dot marks, but what I'm really going to do is draw them to the center. So connect that little tick thingy that I did to the center, but I'm just going to stop right at the circle because that's what I'm really looking for, is the point on the circle. So I'm going to do the same thing for all three. Okay. Like that. And then like this. Like that. Okay. So 0 degrees corresponds to 0 here, which is flat, just straight across like this, and the positive x-axis on the x-axis, right? That point is associated with 0 degrees. And what are the coordinates of this point? We actually know it from the picture. If you remember how to plot points on the xy coordinate plane, this would be 1, 0, right? 1, 0. You can either think of that as I'm starting at 0, 0, and I'm going right 1 unit, so positive 1, and I'm not going up or down anywhere, so 0. Or you can just read straight off the x-axis and see a 1. So 1, 0 is associated with 0 degrees, right? 0 degrees. And then this is 30 degrees, right? Because we measured it so that it was that case. So we used this and we saw, oh, 30 degrees. So this point on the unit circle is associated with 30 degrees, because if I were to draw the line or a segment between that point on the circle to the center, I make an angle of 30 degrees with the positive x-axis. this is 30 degrees. And remember, angles are just the angles. It's not the actual distance or anything, right? If it were distance, this distance would be bigger than this. But we're talking about the angle itself. So this is 30 degrees. So the point that is associated with 30 degrees, and this is what you can start memorizing if you don't already know it, is this has a coordinate of, has coordinates, because remember we have ordered pairs. So we have root 3 over 2, comma 1/2. So I'm basically, to find that point, I'm going to the right, root 3 over 2, and then up 1/2. And we have to use geometry to figure out how on earth would you have ever known root 3 over 2. And this is what I mean. You can't get an exact value for root 3 over 2. So you have to actually use geometry to get that exact value. So you're going to be using the Pythagorean theorem, but you have to be clever in how you derive this. So we'll do that in the future. But you can kind of see the half. You can kind of estimate that root 3 over 2 is going to be less than 1, so that's pretty good. And then half, this looks like it's about halfway from 0 to 1, so I mean, you can kind of eyeball it, but for sure that's the exact value for 30 degrees. This angle here is 45 degrees. So that's what we mean by the angle associated to a point is the angle you get when you draw the segment from here to from the point itself to 0, 0, and then seeing, starting from your positive x, moving to that line, what angle gets created. That's what we mean by the angle associated with a point. So this is 45 degrees, and those coordinates are root 2 over 2 and root 2 over 2. So this is just, I'm telling it to you now. Maybe you've heard of it before and you're just working on memorizing them, or you've been told to just memorize it, or you're seeing it for the first time. But I'm not like calculating anything right now off the top of my head to get these. I've just memorized them, and then we will go into the derivation of where they come from. Okay, and then this is 60 degrees. So from the 0 part to that is 60 degrees, and that for 60 degrees the coordinates are just flipped from 30 degrees. So it's a half, comma, root 3 over 2. Okay. So then what is the angle at this point right here? What is the angle that's associated with that? Well, you can either see that this is a right angle going from the positive x to that is 90 degrees. It's a right angle. Or you can think of it as being a quarter of the way all the way around the circle. So if we go all the way around the circle one time, that's 360 degrees. We get back to where we started. And this would be a quarter of the way. And a quarter of 360 is 90. So this is 90 degrees. Okay. And like I said, all the way back around is also 360 degrees. So 360 degrees and 0 degrees are the same, as far as this is concerned, right? And what are the coordinates of this? This you don't even have to memorize. If you have this picture in your mind, you know that this is 0, 1, because I'm going up 1. So I'll just write 0, 1. Fantastic. So we have these special angles in quadrant 1. In quadrant 1. Okay, which is just this bit. Cool. Okay, so like I said, we will derive where these values come from in another video. I'll probably start with 45 degrees, and then as you can see, 30 and 60 are the same coordinates but flipped, so we'll use symmetry there. And then for these two, you can read just straight off of your 0, and 0, 1. So what is cool about this is once we really fill in all of this and we tie it back into our trig functions, our trig functions of sine and cosine, we can see that the cosine of our angle, whichever angle we're talking about, is actually the x coordinate, and the sine of our angle is the y coordinate. And if you want to see the derivation of that, that's in my intro to trig video, but we might break that down again in the future, but I'll link that below. So basically it comes from writing the just drawing a right triangle, bringing your point straight down. You'll see that that has y, and horizontally it would be x, and using SOHCAHTOA, but realizing that the hypotenuse of all of our right triangles are going to be 1, we realize that sine of the angle, for instance, is opposite of hypotenuse, so y over 1, which is y. So cosine of our angle is, so cosine of theta, where theta is our angle, right? So our theta is our angle, wherever that may be, is our x coordinate, and sine theta is our y coordinate. So our trig functions give us a way to connect angles to just a number, a ratio of sides is what it really means, but it's so cool to take an angle to a number. So, and then of course from there we can figure out all of our other trig functions, like tangent is sine over cosine, and all the other ones can be written in terms of sine and cosine. But the most direct that we can see on this circle is x and y, which are cosine and sine. So now that we've memorized this, we can actually write out a table, which we'll do later on. But like I said, I wanted to focus on drawing the circle out today. But you can see just straight out from this information that, for instance, 0 degrees right here, cosine of 0 is 1, and sine of 0 is 0. Just because the first term is always the cosine of the angle, and the second is sine. So cosine of 90 is 0, sine of 90 is 1. Cosine of 60 is 1/2. Sine of 60 degrees is square root of 3 over 2. Isn't that so cool? So this is just quadrant 1, and I guess we should probably write the radian equivalent. So if you want, you can just practice converting these into radians by dividing by 180 and multiplying by pi, because remember, pi radians is 180 degrees, so you can just set a ratio from there. But once you practice this a whole bunch, you'll start seeing, you'll see it over and over again, so you'll know this 0 is 0 radians, and it's also 2 pi. Since pi is 180, 2 times 180 is 360, so 0 and 2 pi. 30 degrees is pi over 6. Okay. 45 degrees is pi over 4. Okay. So again, like 30 divided by 180 is 1/6, and then times pi, so pi over 6, pi over 4, pi over 3, and then 90 degrees is pi over 2. Right? Since 90 over 180 is 1/2 times pi. So pi over 6, pi over 4, pi over 3, and pi over 2. So you can kind of start seeing patterns like, okay, well, if it's a 30 degrees, it's pi over 6, but if it's a 60 degrees, it's pi over 3. You can play little games with yourself like that. But whether you do it in radians or degrees, you can get these exact values. Okay, so now in order to fill out the rest of the unit circle, since we focused just on quadrant 1, we're going to use symmetry for the rest of this, for the other quadrants. But these are the only actual magnitude values that we have to memorize or work on memorizing. Okay. So just these, because the rest of it is about adding positive or negative signs and knowing when to do which, but that's it, okay? So for instance, let's work on quadrant 2. So what we can do is basically mirror this over here. So symmetry, I'm gonna flip this whole thing over onto this side, okay, like this. But since I want to stay sort of accurate here, I'm going to still use my protractor for quadrant 2. But I'm basically, if for instance from 90 degrees to 60 degrees is 30 degrees, that's a 30-degree angle, right? Because remember, everything is relative to this 0. So 0 to this is 60 degrees, but 0 all the way is 90 degrees. Then the difference is that little angle there. So if this is 30 degrees, I'm going to mirror that over here to 30 degrees as well. Or another way to do it is to just start with your protractor again. Take your protractor, place it back on the 0, and instead of this being, you're just literally flipping it. So instead of this being 0 this time, this is 0. So I'm going to go 30, 45, and 60 degrees going this way rather than this way. So 30 is here, 45 is right there between 40 and 50, and then 60 is right there again. And again, I did the same thing. I'm going to draw from that to the center, but I'm going to just stop at the circle to get my point. Then from here to here to get my point. And then from here to here to get my point. Okay, so basically I mirrored it. I reflected it across the y-axis here, okay? So that if this was 30 degrees, this is 30 degrees now. And this was 45, so this is 45. And if this was 60, this is 60, okay? And the reason I wanted to do that is because if I drew my right triangles, like I said, that's how I got these exact values, is by drawing right triangles and working with them. You'll see that if I flipped it across, this is the same right triangle as this, just flipped, but it should have the same distances, right? The vertical part should be the same, the horizontal part should be the same. It's just that I need to include a negative sign for the x part because I'm going left for the actual units, right? So first, let's fill in what the actual angles are just by realizing that I'm taking my special angles and putting them over here. So what I'm really doing is this point right here is what the actual coordinates are, -1, 0, right? I don't have to memorize anything there. I'm just reading straight off. I'm going left 1 and not going up or down. So -1, 0, or just reading off of that point right there. But this angle is 180 degrees. Remember, we're always starting from positive x-axis, the positive x-axis, and moving our way around. So we're moving our way around here. That's the positive angle direction, okay? So the straight line, the full line, is 180 degrees. So this is 180 degrees, which is pi radians, okay? So that's pi radians. That's our coordinates for that. And so for these, we can actually use this and kind of work like 180 minus this is 30 degrees, so this was 30 degrees, so this is 150 degrees. Okay, so I'm not really memorizing anything, I'm just kind of trying to use geometry and being clever here. So this is 150 degrees, and then this would be 45. So this is 45, so 180 minus 45 degrees is 135 degrees. And then 180 minus 60 is 120 degrees. So this is 120 degrees. And what is 120 degrees? Remember, we're starting from the positive x going to our point. So that is 120 degrees. And then it gets really messy trying to write this out, but that is 135 degrees. That. So just because I'm using the 180 and going backwards here, remember everything is still relative to this part going this way. So, you know, you could have found these values using other stuff like, okay, well, if this is 90 and this is 60, this is 30 degrees. So 30 degrees more than 90 is 120. So you can kind of do it this way if you want to, but whichever way is convenient. I like to think of it as 180 minus stuff, but that angle itself, remember, is always relative to the 0. So then, of course, you can do the same with radians. You can either try and convert them, or you can do pi minus pi over 6 is 5 pi over 6, that kind of stuff. Or you can just divide by 180 and multiply by pi for each of these values, whichever way you like. So pi minus pi over 6 is 5 pi over 6. And then pi minus pi over 4 is 3 pi over 4. And then pi minus pi over 3 is 2 pi over 3. And the reason why I'm writing every single one out right now is because it can be tricky. So I wanted to just write this out so we have one thing once and for all. Okay, so now as far as the actual xy coordinates go, we can just use these values, especially these three, right? Because we can figure this out just by looking at it, the negative 1, 0. But for these three in the middle here, we use the same values, the same magnitude, because like we said, it's the same triangle, but it's flipped. So in quadrant 2, my x is negative and my y is positive because I'm going left and up. So this is going to be the same as that, but negative root 3 over 2 and positive 1/2. And this is going to be the same as this one, the 3 pi over 4 is going to be negative root 2 over 2 and positive root 2 over 2. And then this is negative 1/2 positive root 3 over 2. That's it. And then we have our 0, 1, which is the same. So it's not like you have to memorize every single one if it's positive or negative, and then memorize the half and the root 3 over 2. You just need to know this quadrant 1, and then find which quadrant your angle is in, and then remember, or not even memorize, but just look on your paper if x is negative, or if y is positive, or if x is positive and y is negative, and you just tack that on, and that's all that you need to do. So now that I did these two, I can actually reflect over to 3 and 4 pretty easily just by extending them, thankfully. I don't have to actually recalculate or remeasure. I can just extend across 180. So this one here. So I'm just going to go ahead and draw those in as well. Okay, very good. And then this goes across here like this. And then this goes across here like this. And then this goes across here like this. Okay. Nice. So just this. So now, again, just can keep the same coordinates, but we need to keep track of what's negative and what's positive. So for quadrant 3, we have, well, let's write out our angles first. So this is going to be 30 degrees, okay? So it's always going to be this like 30, 45, 60 pattern. So this is going to be 30, 45, and 60 degrees past 180, because remember it's always relative to this. So I'm going 180 plus 30, 180 plus 45, 180 plus 60. So that will be 210 degrees, 225 degrees, and what is it, 240 degrees. And then relative to, in radians, that's going to be pi plus pi over 6, right? Because pi plus, or pi over 6, is 7 pi over 6. And then pi plus pi over 4 is 5 pi over 4. And then pi plus pi over 3 is 4 pi over 3. Or you can just multiply by pi over 180 to get these as well, just converting it regularly. So then we have our actual coordinates, which would be, oh, and let's do this one too. This is 270 degrees, right? So we're 3/4 of the way all the way around. So 270 degrees is 3 pi over 2. And our coordinates are just going to be negative x, negative y. So it was root 3 over 2 and a half. So now it's negative root 3 over 2, negative 1/2. It was root 2 over 2 and root 2 over 2. So negative root 2 over 2, negative root 2 over 2. And then half and root 3 over 2. So negative 1/2, negative root 3 over 2. And one thing that helps me to make sure that I'm on the right track is to sort of visually see which one is bigger. Like this is negative, and then this is longer, so it's over a little bit and then down more. So half is less than root 3 over 2. So it's over and then down more. And then the 45 degree one should be exactly the same. So you should sort of be able to eyeball it and it should look right. Especially for pi over 6 and pi over 3, it's easy to get them confused. So that's my little trick there. And so, yeah, so now we have more values. But you see, we're not really memorizing, right? We're just trying to notice, okay, in quadrant 3, it's going to be negative and negative, positive, positive, negative, positive, negative, negative. And then let's keep moving along. Oh, and then for 270 degrees, just straight right here, we can read this straight off of the picture and get 0, negative 1. Right, cool. And then here, again, you can either think of it as, 360 minus this bit, which is the same as the 30 degrees, because we're reflecting across the x-axis. So this is 30 degrees, so you can think of it as this is 330 degrees. Or you can move along this way, whichever, or you can just do this plus 180 degrees. So there's a lot of ways now, just based on all the symmetry, to go with this to fill in the rest. But you could do 360 minus 45, so 315 degrees, and then 360 minus 60 degrees is 300 degrees, like that. And then we'll do the radians. So the radians will be 5 pi over 3 and 7 pi over 4 So now to find the coordinates again, in this quadrant you have positive x, negative y. So for 300 degrees, it's going to be that's going to be this one. So that's going to be 1/2, negative root 3 over 2. This is going to be root 2 over 2, negative root 2 over 2. And then this is going to be root 3 over 2 and negative 1/2. Okay. So, and then we're back to where we started. So I know that this was a bit tedious and this looks really wild, but I wanted to take the time to look at these angles in radians and in degrees. One, because it does confuse me all the time too with the mirroring and what the actual values are. But I also wanted to show you that all the values are actually the same and based off of symmetry from this first quadrant. So I hope that is interesting. And then remember, if you want to go a step ahead, remember that the x coordinate is cosine of my angle. So for instance, cosine of 315 degrees is root 2 over 2, and sine of 315 degrees is negative root 2 over 2. So you can take it a step further from there. But for now, I would highly recommend memorizing these values here in quadrant 1. This is our friend, and also you might as well get used to 0 and 90, but that's not something to memorize. You can actually just draw this out, and if you really understand what's going on, that's not anything that you actually have to be scared of or memorize, because it's 1, 0 and 0, 1. So if you memorize these, you can get the rest of this. But I wanted to still draw it out because it's easy to just say, oh yeah, we're gonna reflect this. But believe me, I've gotten all these angles like confused so much too, because I'm like, wait, if we're reflecting, how much am I adding 30 or am I adding 60? And so I guess in this picture, I hope it's still nice looking, but it should be pretty clear that I am reflecting across, but it can be kind of tricky. And even as it is here, even just because I'm doing this by hand, the picture's not going to be exactly symmetric, but I try. So like even here, I know that it's not exactly symmetric, but it should be. So I recommend that you look up a version online and even make one for yourself. This one's a little one for me, and so this was a lot of work, so I think we deserve a sticker. What do you think? I think so. I definitely think so. So nice job, nice job. I hope that this was interesting. It's kind of hard to talk and write at the same time, so I'm sorry if it's not like totally symmetric. I'm practicing. But hopefully you can get yourself